All right, so that question, there's your graph. So for example, there's one direct route between cities 2 and 3 on the top. There's 2 direct routes between 3 and 5 on that left vertical edge, and so on. So the matrix they want you to fill in is basically just showing the number of direct routes between 2 cities. So the diagonal is 0, right? So they're defining the number of direct routes from a city to itself is 0. So the top row, so from city 1 to 1 is going to be 0, right? So I'll put a 0 in that diagonal spot. The number of direct routes from city 1 to city 2 is 3. So I'll put a 3 in that next spot. Direct routes from city 1 to city 3 is 0, right? Because there's no edge there, so I'll put a 0 in that spot. From 1 to 4, there's 2, and from 1 to 5, there's 1. So the top row of the matrix would look like that. You just what?
You're just counting the direct routes.
You're just counting direct routes, which means if there's not an edge, there's no direct routes, so at the entries is 0. So you're not actually doing any work. You're really just taking what's already on that graph and putting it into a matrix form. And it's not the adjacency matrix or the incidence matrix or any of that stuff that we talked about. It's a totally different thing. It's just what they're doing in this particular problem. So other questions, either on the homework or on languages? What do we want for C? So calculate a squared, you're going to get another matrix. And if you look at, the entry in some particular row in some particular column, presumably it's saying something related to this city and that city, right? So in the original matrix, if we look at some row and column, this entry tells us the number of direct routes between whatever this city is and whatever this city is, right? So if we're in row 2, column 4, this is the number of direct routes between cities 2 and 4. So when you take a squared, look at your resulting matrix, think about, okay, this corresponds to something about cities 2 and cities 4, and take a look at your graph and see if you can figure out where that number has some meaning, right? So it's kind of an open-ended question, but there's a fairly specific answer that may or may not jump out at you. So it's a little open-ended, but look at a squared, look at the graph, think about how it might relate to some information about the cities, and see if you can figure it out from there. Other questions? All right, so let's continue with languages and phrase structure grammars and things like that. So I think junior year, you typically take an entire course in this stuff. So this is really kind of a first exposure. But most computer science programs have an entire course called automata theory, and that's kind of what we're dealing with in this unit on languages is automata theory. But we're touching on different aspects of it. So let's try another synthesis. So we have a phrase structure grammar, and its language looks like this. And I'm using this shorthand notation to say that the words that belong to this language are everything of this form, some sequence of zeros followed by some sequence of ones. And the number of zeros or ones must be bigger than or equal to 0. So for example, right, that's definitely a word over this language. It's 3 zeros followed by 4 ones. This is also a valid word. It's 2 zeros followed by 0 ones, right, and n is allowed to be 0. This is also a word. This is a word. This is a word. And this is also a word, because m and n could both be 0, in which case this shorthand up here says 0 zeros followed by 0 ones. That's just an empty string. So any of these things should be recognized by our grammar. So again, we want our vocabulary to contain at least a 0, a 1, and a start symbol. S is going to be our start symbol. Our terminals will be just 0 and 1, because every word recognized by this contains at most some zeros and ones. And now we want to set up production rules. So play around with this for a few minutes. Work with someone next to you if you like, or work alone. And start tossing out some ideas when you've got them. And we'll play with it and see what we come up with.
Lambda technically be included in the vocabulary?
Say what?
Is lambda technically included in the vocabulary?
No, lambda's not a symbol. Lambda is an empty string, actually. So it's not a part of the vocabulary. Whatever's in the vocabulary, if we take none of the symbols from there and put that together in a string, that's lambda. It's a little weird. But it's a string containing no symbols, but it's not a symbol itself. It's a little bit maybe like the difference between this and this. Right, lambda's more like this. But if that's confusing, forget I said it. So any ideas?
S can go to A, or S can go to B.
Okay, so let's put A and B in here. Okay.
S can go to lambda.
S can go to lambda, good. That's definitely a safe production rule because we know lambda is a recognized string. It's a part of the language. S can go to AB.
And then A can go to AA, and B can go to BB.
This is sounding a little like Wednesday, which isn't bad. So now for my start symbol, I can get to a bunch of A's and I can get to a bunch of B's.
A can go to 1, B can go to 0.
I think this is reverse.
Other way around.
Probably the other way around since we've always got A coming before B.
A can go to lambda, B can go to lambda. Oh, wait. There's redundancy.
You might need that, actually,
So that you can get.
because we want to be able to get something like that and that.
Well, you
We don't need it. We could just go S to B.
A and the S to B.
Right.
There are two different ways to go around doing that.
So we may not need those.
Yeah, they can use things, yes, can go to A, and S can go to B, and S goes to lambda. Those three, the last two are the first three.
So this will get us to a bunch of A's, which will ultimately be zeros. This will get us to a bunch of B's, which are ultimately ones. This will get us to a bunch of zeros followed by a bunch of ones. So I'm liking this for the most part. I think this probably gets what we're after. But I'm going to point out one technical detail with this. And this is a little subtle, but think about it. We're saying that A can be replaced by A followed by A, right? So if we were to try to make one of these derivation trees we've been doing, we could start with S, we could replace that with A, which could be replaced with two A's, which could be replaced with more A's. And let me offer you an alternative to this, and let's compare the experiences. Suppose we say A can go to 0A, or B can go to 1B, instead of doing these.
That works too.
I think that works too, but it has an advantage. Because if we have a string like, well, let's see. Suppose this is our string. And we want to know, is this recognized by our language? Well, we could start off with this string. We could say, okay, so is this an A? And we could say, is this an A? This 0 followed by a 1. Well, if it's an A, it would be an A followed by another A. I don't think I have the vocabulary right now to describe this. When we start using these to actually process strings and see whether or not they're a part of the language, we're going to do this recursively. Okay, we're going to have a rule, for example, that says this part of the string is an A if it's an A followed by an A. Okay? And that kind of recursive definition is never going to end. Because to say this is an A if it's an A followed by an A, well, first we're going to have to see if it begins with an A. And our definition is going to say, well, if it's an A followed by an A, so we're going to have to see if it begins with an A. And we're going to keep doing that, and it's never going to come back out of the rabbit hole. If we have some terminals in here, we can say, okay, is it a 0 followed by an A? So we say, okay, there's a 0, we pull that out of our string. Is the remainder of it an A? And now the thing that we're working on is a little smaller. And if we keep doing that, eventually we're going to run out of symbols, and we'll get down to something that matches or doesn't match. This is not a great example for showing that, but when we come to another one, we'll talk about it. But yeah, this will work, right? You've got the idea, definitely. All right, so let's go on the boards and try some other synthesis. So go ahead and make a phrase structure grammar that recognizes a sequence of one or more zeros. So find a board and some groups.
forgot how to like parse this. So we would say our vocab.
It's just zero.
Start.
Almost too easy. Almost too.
Well, actually, I don't know if that's included in there.
Or like,
You want it to be bigger than or equal to 1. So try for it.
S goes to S0. Or no, S just goes. S goes.
Actually, if n is 0, yeah, it goes to
You want to go? Can you have S go to 0, A, then A go to 0, or A go to lambda?
0 or 0, 0 or 0.
Okay, try for n bigger than or equal to 2. So I think that's right.
And that'll give us infinite 0. At least one. Yeah.
Yeah, these are productions.
Do you have a way to present?
yeah, we put it on our I installed Windows.
Do that to get
Oh, wait, you were.
I did it in earlier class because the rest of my
That makes sense.
welcome to.
and even then.
Well, you weren't here. Like everyone.
Yeah. Actually, it doesn't need
Oh,
to
is
be.
it like that in the earlier class? Everyone's going like above me now, doing all sorts of crap.
I did the bare minimum.
Yeah, I did the bare minimum too.
It took me 20 hours just to do the bare minimum. I was done with that. And I did it like, I just gave up on it.
So if you nailed this one, go ahead. Try for n bigger than or equal to 2. See how that changes things.
0.
This goes to AA. So it's just n bigger than or equal to 2.
That's why
We could also do.
one just greater than 1 works
Oh,
too.
yeah, that's true.
And you erase the equal sign.
So that's goes to A.
But can't you technically break it because you could add certain S? Oh wait, no. Yeah.
You can't break that.
I see.
Foolproof. Dumb.
Sneak the double A.
Or I saw the values. Because anyone whose values were correct. No one's
We all got like 38
I got the weight and the angle of it was the X. The only thing that was off was the X. Way off. That's 16 centimeters off. But I was like 5 minutes off on the weight and like 4 degrees off.
Yeah, that would be.
Yeah, I didn't see. Yeah, there wasn't even. You're just supposed to get that. Cool.
Well, it was awesome.
All right, so let me give you a couple of other ones to work on.
I don't think he's everything.
Yeah.
Introduced another variable.
There was that one day that took us a while to figure one out.
You could
That was
throw
that
B
one.
in there, but it would be also.
Yeah.
It's just-
Actually,
because we're having two variables like this.
Oh.
All right, so there's two more languages to work on. The first one is 0 or more ones, followed finally by 1 0. And the third one is 1 or more groups of 3 zeros. So 3 zeros, 6 zeros, 9 zeros, etc.
This one. So the start goes to B just goes to
No, like I was
A can go to
Oh, yeah. And then, third one,
0 0 0.
you just do what you do.
It is good.
Can you just say, yeah, it's like 0 0
Three and 3 zeros and then
2 zeros? Because the A is going to become 0.
1. So A is going to become 3.
Keep all the so that.
Okay. So you say A is 3 and
Or
Okay, so A can go to
we can just add
you just wrote down the problem.
I was actually wondering about the 0 and 1. Couldn't you do it really simply myself?
It's the same thing here with the original one that we did here, only replaced the zero that's 1. You could put 3 zeros. Now you can't do it.
I was confusing myself, so I was like, oh, you can't get the first 30.
But I'm not sure if I can spell it.
I did that.
Like a null or not, or just be interpreted as like.
Lambda is just like an input.
Yeah, there's.
Oh, then this is just nothing.
That would be the idea.
That works.
So we know that we can have more.
That's like a tooling program rather than.
Alright. So it's.
I'm like, you're rubbing something on the whiteboard, must be an array for a while. You will be nice.
Yeah, I mean,
Kind of present you as
But you get whiteboard, you don't really need it.
I would go for that. Yeah.
a lot of people.
I thought it
Every high school is like
That
that.
class is really good.
It took a lot of time.
Higher thing would not.
Seriously, some people are taking like 15 minutes.
Whiteboard.
I think only like the first year took that long.
That's.
yeah.
They really should have
I actually didn't have a computer until now. I think it was
You know, they have to do it. This way I
not that, but now I'm like, oh,
Those
that's what I get
metal
out.
like
I don't
schools
like
that are like way too short. Tables that are like too
I
short.
just stole my sister's Windows that she never used. I put Linux Mint on it and white.
The little white square tables
It
are
all
to be useful for
Linux
anything.
systems to get
They're
Unity
whiteboards.
working, but I always.
There's just no like markers to use for
The
things.
most modern Linux distro.
Here's the thing, on my Chrome OS,
Yeah, well,
it's
well,
a
they
special
have to
processor, it's like an RZ7. The only Linux distro that I can actually run on it is Arch Linux, which is basically screwed up.
Yeah, Arch Linux I really have. Arch Linux is pretty, it's not really user friendly or whatever. It's just like boring stuff.
that 1A go to 4As.
Yes.
Yeah, I just use Linux Mint, but yeah, it's probably different processor.
That's a much simpler solution.
Maybe the show is getting Zenity was on the X server or something. They actually store the box. And just couldn't fit in
It's
that.
usually like GPU.
If it's only in this format, 'cause I put 2A or
The letters usually external
format.
some sort of GPU driver.
Yeah,
And then
we did
you
A
go to
to A,
format
and then
that
I
fits
got
what
those.
you're
Getting on a whole like sword.
Yeah.
So you just erase the last bit.
Yeah, yeah. I would actually erase the first A and put 0, 0, 0 on the end. We'll talk about why.
It actually worked, which was nice.
Yeah, yeah.
So here's
As long as, no,
Like,
it'll be 0, 0, 0,
right, so suppose you're
this
starting.
doesn't work.
Yeah, no, that's what we got there.
Oh, that way, when you, same way as before, if the agent.
Yeah, it's like, is this an A? Well, I don't know, let's see, is it an A?
Because it's for 0.
No,
It's n greater than or equal to 0.
So you get that same issue.
Yeah, and you never.
So there can be
assume
0,
anything
1.
like this.
With this, there will always be at least one.
Okay, so it's 3 zeros, yes. So is the rest of this an A?
So if you did
No, you can still start at the beginning. Yeah, well, even if you did it this way.
Yeah.
And you just pick one, and then it goes.
Yeah, yeah,
That way it'll actually terminate.
This way you're.
Well,
right, right.
Because like before, if we have one A, that A will never terminate. It will continue existing forever. Like this, you can keep duplicating.
And there's types of grammars, Chomsky grammars, and there's type 2 something else, and so on and so forth. And they have to do with these nuances. And we're not getting into that here, that's what we're getting into
So that A would go
But
to A,
but basic behavior of these things, we got it. That's all we're after.
and we'll ultimately, if you chose to stop it.
So we need to turn in rotation for homework. Where's her office at? I've never been to her office.
I'm not sure if the Dropbox is outside or it's somewhere. It says physics Dropbox on it. I hope there's not more than one.
I thought she said the class was outside her office.
I think her office is between here and the laboratory. If it's not there, then it belongs to the
Best for those
laboratory.
water bottles that we're all doing. So everyone who yeah, they go to
It was the first time I left my watch. When did the extension?
I said to specify it's a professor name, so I think it might be like a communal thing.
Because I thought it was
When did you get out of
I used to return that.
Do you remember the time? I got like 1.5.
Sound about it.
Is this?
I got like 2 squared.
Something like one.
2 squared was 1.25.
got your water
Yeah, it was
Are you doing the lab next week?
Yeah, because there's a different view. It's like everybody's just too lazy to do the work. I do.
Yeah, I'm pretty sure it's.
Everything.
I'm sticking it.
2 other questions.
Because I have turned the other one and the SLP calculations
Going over 2 things.
are during the same time.
Very specific questions for sampling.
So,
Taking notes because. Oh, okay.
The report, right?
no.
The one we have to.
SLP
No,
is
no, no,
CSE
that's-
224,
oh.
223, 222.
That's for the projects like Black Series. So, no,
Yeah. The physics project, that's during class.
No, we have to present.
Yeah. Although our class is so far behind on the issue. So we're not going to be doing the
Next week, like, yeah.
for the
Yes,
project.
next week's the last week.
At least my class has one. I have a grade for 241.
Finals for this
Physics project.
This class is finals on Monday, right?
Did you do the Pascals?
I just did that in class during the break.
It wasn't too long.
Yeah,
Yeah,
like,
No, well, Monday of finals.
okay, I was like, I don't know, next Monday.
I was actually, I kept getting like this stacks initiative, and I was like, oh, I defined like a variable for the next row in multiple places.
I wasn't initializing all my arrays, so like half the numbers to 0. And I kept getting like the last two numbers in front, that was like 554 billion.
Yeah, I had that at first. The solution was just to store like the last line as a temporary
I know with grade.
and then use that for automation.
So I just initialized all the integer values.
As far as I'm aware, it's all worked out.
Yeah, it's to get to the extra grade.
I'd like to see what your solution was.
So does Nebraska
I can't imagine doing without like storing the last line.
I didn't store the last one. I created like a two-dimensional array of integers, like I made 20 by 20.
Oh, a 2D.
Yeah, I made 2D arrays. So like basically an array for each line, and then like just an array of lines.
Oh, so I used
none of the other ones.
I used it with tons of triangle arrays.
There's a reason why Charlotte.
So basically, every array here is too long, but
All the other physics.
I use like looping, so like I loop through all the rows I want to print out, and then I would loop through the count of the row that I'm printing out because the length of each row is going to be
So then you get that pen.
same as the
Last one.
And then I just go through and I take the top number. If it's the beginning of a row, I just take the top number and bring it down. If it's in the middle of the row, I take the top number plus the top number plus one over. And then if it's in the end of the row, I just take the top number minus one and bring it down.
Guaranteed only. Everyone else
That's after the first.
yeah, that's after you cut the points down to 80.
This is the easy one.
Well, this is the easy physics the hardest one trying to understand physics. Starts up here, and the homework is finding out. You don't know why.
Well, sometimes Sharp has the same problem. She looks like the same one.
And that's where we go to lambda.
No, that's only the labs. The homeworks is only one.
And then
It's only with the labs.
Yeah,
Because you have the lab instructions,
classes I did,
lab document and stuff. And then you have 3 labs. All of which are the same lab. Therefore, you have 3 labs.
And then,
It's a,
yeah, physics, lecture is independent of classes, independent of calculations. You have to pass all.
alright, cool, I like that one. So what it's gonna do is have to piece everything.
You can fail and not do it.
But I went up to take classes. So,
I have to show 6 so I got my 6, so I wish I would have come in.
That's why I was working.
Yes, it is.
I use that time to catch up on the physics homework.
This goes to A, B, B is a 0.
Pull a step in, how terrible it is, how weird our schedule is. Instead of just counting it on the side, it says, all right, it's
Okay, cool.
because
A, 0.
original due date was like
Okay, cool.
2 weeks ago,
That's good.
it's covered material and
You have no idea what it is.
Yeah.
we got to that. So when we were in the lab though, we had to hear so I had
Okay, I tried out things I don't understand.
and that's how I know.
Really tall.
Grades level.
Okay, or if you got 2 minutes after class,
That's what I'm
you can try it out. Okay.
Yeah.
Nothing changed? Okay, good.
Do you have any like one project? Well, like anything like sports.
I did it for 2.4.
You can take a whole class and it's like
couple weeks ago, to see like all of them, just pull them all at once.
Well, we have all these sports signs. That's why
We already have it. Oh, right, we're doing that as a PDF.
It's like searching. I never actually played. It's like searching for something. I go.
Yeah, so you can see
That's why I use the array of arrays.
Yeah.
Yeah.
Well, a lot of
This is a middle. But knowing Clarkson's got a any number in the middle is
I just use them. He has to print it 15. It's pretty easy to edit. Whatever size, final size.
Just change these like 30.
Well, like every time you call, it's like these between 2 at a time.
good response.
Although I did have to print out like the first. They do the same thing.
Yeah.
I didn't actually do that.
The first row and then I was like initialize it to 1 to get the picture.
I had a friend who was playing it all was like,
Like my way was way too, I would set the beginning and the end equals I'm not sure if I even
well, Fortnite is cheaper.
It's free.
So you have that advantage.
Or one followed by
The
B,
price
or
is
one
pretty
followed by B.
That's what people play.
Yeah, that was.
Yeah, you
Well, actually, this was I had to put it into a variable because for some reason when I was doing like the beginning of line name and then bar, it wasn't working. There was another one similar to AT, but it's Battle Royale. I mean, not Battle Royale.
I actually did like a main program, like there was a main
Everyone spawns in
second and you use the reservation.
go into the dive and you die. Call of Duty usually didn't do that, and you was Call of Duty. That's really what they're trying to do.
I guess so.
Well, you can modify it. This is my sister's one. I just saw one.
All right, so I think you've got the hang of this. Let's go over one detail. So here's what I was saying a few minutes ago about the order, putting the A first or putting the A last. Let me look at a different example. So let's do 0 to the n where n is bigger than or equal to 1. Doesn't really matter. All right, so the usual terminals and vocabulary and start symbol, I'm not going to write those, but let's look at our productions. So our start symbol could go to 0, or it could go to 0 followed by an A, and A could be a 0, or A could be a 0 followed by an A. little differently. Okay, this one's a little easier to think about. So we're saying that our start symbol goes to an A, and what is an A? We want A to be just a pattern of one or more zeros, right? So A is either a 0 or it's a 0 followed by an A, right? So if we have something like our start symbol, it becomes an A. That can be a 0 followed by an A, which is a 0 followed by a 0 followed by an A, and maybe this A is just a 0. So there's 3 zeros. Okay, so let me write something that feels equivalent to this. All right, exactly the same, except my last production rule says A goes to A followed by a 0. Okay, so here's why I'm going to say we should probably avoid this type of production rule. So imagine you're writing code that's going to take a string and see if these production rules get you from the start symbol to that string, right? So if your string is a 0, we can say, what is a 0? Well, it could be an A, and an A comes from our start symbol, right? That looks fine. But in general, suppose we have some string. So let's say it's a 110. And we want to know, is this recognized by this phrase structure grammar? So we're kind of working backwards, right? We're trying to show that we can get to this from the start symbol. So typically we would write a function which says, is this an S? Is it equivalent to an S? Is it derivable from an S? And that would say, well, if it's derivable from an A, then the answer is yes. And then we have something which says, is this derivable from an A? Well, if it's a 0, it'll come back and return yes, it is derivable from an A. If it's an A followed by a 0, it'll also come back and say, yes, it's derivable from an A. But how are we going to write this function, derivable from A, recursively saying, okay, first see if our argument is derivable from A, and then see if what's left over is a 0. Well, when we call this function to say, is this argument derivable from an A, the first thing that function is going to do is say, is that argument derivable from an A? And it's the same argument, right? So if this is our string, and we're saying, is this derivable from an A? Well, we have to ask the question, if we start at this point, is this an A? From this point going somewhere forward. And it's not a 0, but it could be an A followed by a 0. So to tell if it's an A followed by a 0, we have to say, okay, starting at this point, is this an A? Right? And it's not a 0, but it could be an A followed by a 0, so now we have to say, starting at this point is an A, and we're going to run out of paper, we're going to run out of memory. Right? Our recursion will blow up our stack eventually. Now with this, right, so let's say our string looks like this. We can say, is this an A? And yeah, we'll say, is this a 0? And it is, so the rest of the string has to be an A. So now we're asking a different question. We're asking, is 0101 an A? Right? And it's not a 0, it's bigger than that, but it could be a 0 followed by an A. Well, this is a 0. So now our question is this an A? And we're asking a simpler question now, is 101 an A? And this is not equal to 0, so it's not under this production rule. It could be a 0 followed by an A. Well, this is not 0. So neither of these production rules applies, and at that point we can say this is not an A, which means this is not an A, which means this is not an A. So the difference is, with this rule, in some sense, we're consuming characters from our string, as we apply these rules. And our string will get shorter and shorter until it either becomes empty and doesn't match any of our rules, or it matches one of our rules like this. Right? Whereas like this, we risk sort of infinite recursion. So that's a nuance. And as I was telling some people in the back, when you take a course in this, you learn about different kinds of grammars, type 2 and type 3 and Chomsky hierarchies and all sorts of different things. And the differences from one grammar to another are things like, can you write an expression like this? Or do you have to have terminal symbols in the beginning of the right-hand side and so on? And those are details I'm not going to worry about, okay? But in general, when you're writing these things for this course, I would suggest if you have A, don't change it into something that starts with an A, right? If you have a B, don't change it into something that starts with a B, because it makes it harder to parse. And ultimately, this is about parsing, okay? So parsing is taking some set of input and seeing how it fits into some kind of language, right? So diagramming a sentence, for example, or taking a piece of C code and saying this is a function definition, this is an argument list. The argument list is a type of variable followed by a variable name, followed by a comma, followed by another type and variable, and so on. All right, where do I want to go from here? So any questions on this phrase structure grammar? I think you've got the hang of it. All right, I'm going to mention BNF. I don't want to do state machines right now. We'll do those on Monday. BNF is Backus-Nauer form. It's a very different way of specifying syntax, specifying what's valid syntax in a language. And it has a general form like this. So we're going to put things inside angle brackets, and these are going to be noun, verb, adjective, things like that, descriptions of sets of symbols. And we're going to make a series of statements which basically say this symbol called ID is defined as either this, etc. So these pipes are ors, as usual. And things listed side by side are just concatenation. This thing followed by that thing, or this other thing, or something else, right? And any one of these will constitute what we're calling an ID in this case. And we can also have terminal symbols. So we could have something equals, a plus sign or a minus sign. So things in angle brackets are things like article, adjective, adverb, which have to be defined somewhere else. Things that we just put in quotation marks are just bare symbols. Okay, and a plus sign is just a plus sign. So using this, we can specify the syntax of, say, a language or an element of a language. So let's do this for a signed integer. Let's just do this for an integer. So I'm thinking of a non-negative integer here. Okay, an integer that's either 0 or positive. So I can define an integer as being a digit followed by an int, or a digit And a digit is a 0 or a 1 or a 2 or a 9. So let's look at some strings. The number, or the string 1, 2, 3, right? It's not just a single digit, right? Because it's not just a 0, 1, 2, 3, or 5. But it could be a digit followed by an integer. So the question is 2, 3 an integer? Well, it's not just a digit, but it could be a digit 2 followed by an integer 3. So now it depends on the question, is 3 an integer? And an integer could just be a digit, and 3 is a digit. So yes, that's an integer, which means 2, 3 is an integer, which means 1, 2, 3 is an integer. But if we have, the string x, whatever an integer is, it's got to begin with a digit, and x is not a digit, so we know right away that's not an integer. And if we have 1x, well, 1x is not a digit, but it could be a digit followed by an integer. So is x an integer? And it's not a digit followed by an n, and it's not a digit, so no, which means this is not an integer, which means 1x is not an integer. So these two lines basically capture the essence of what it means to be a non-negative integer. Now, if we want a signed integer, which means it could be positive or negative, we can just define that as a sign followed by an int, or maybe just an int. And a sign could be a plus or a minus. That's a quote. And so we've got our regular integers, or an integer with a plus sign in the front, or an integer with a minus sign in the front. And so we can build up from these definitions. For example, we can make a floating point number. And a floating point number is what? Well, let's draw some pictures. So those are definitely floating point numbers. Those are also floating point numbers. That's a floating point. That's a floating point. And so it looks like floating point numbers always start with a signed integer. Optionally followed by a period, and then followed by an unsigned integer. That's these cases. Or it could be a signed int followed by a period with nothing else after it, or it could be just a signed int, which is these cases. And I think that gets us a floating point number. Yeah.
Why is it in single quotes? Why not double quotes?
I switched on it because C uses single quotes for characters, so I just started using single quotes, even though I mistakenly used doubles originally. So what if we want scientific notation?
has to be followed by, it has to be floating points with only one int at the beginning. And it has to be multiplied by 10 to the power of something.
So it's a floating point followed by an e, say exponent, followed by, and it could be positive or negative, so assigned int, or technically it could just be a plain old floating point number, because these things are technically valid numbers in scientific notation, maybe, depending who your chemistry teacher is. But we'll take them as being valid. So in one page, we've already defined a BNF for parsing integers, floating point numbers, and scientific notation, which isn't bad. And this is another one of those hammers that once you start wielding it, you find you can use it to smash lots of problems. So this was one of my big hammers that I probably spent about 3 years wielding, and I wrote compilers and parsers and all kinds of things with this, because not only can this be used to tell whether or not an expression is part of some language, but it can actually be used to analyze that expression and to start interpreting what it means. So let me give you one more BNF, which is for an arithmetic expression. So this is going to be like, I equals I plus 1, or y equals parentheses 2 times x plus 5, close paren, times j. Right? So arithmetic expression is a variable followed by an equal sign followed by an expression. And a variable is going to be a letter followed by a letter or a number or just a letter. And letters are kind of like integers with signs in the front, but the first character of a letter has to be, a variable usually has to be a letter, and then the rest of it can be letters or digits or underscores. So we could define a variable. I'm not going to worry about that right now. I want to look at an expression. So an expression can be defined as an expression followed by an operator followed by an expression, or a parentheses followed by an expression followed by a closed parentheses, or a variable, or a number. And a number is like a assigned integer maybe, or a floating point, or whatever we're allowing. So I've got 4 things an expression can be. It can be an expression, an operator, an expression, or a parentheses, an expression, a closed paren, or a variable, or a number. And this is heavily recursive, right? But if we were to parse something like right, so operator is plus, minus, times, divide, and variables are variables, and numbers are numbers, right? But if we wanted to parse something like this, it's not going to be just a variable or just a number, right? Because it starts with a parenthesis. It's actually not a parentheses followed by an expression followed by a parentheses, unless all of this stuff in here is an expression.
And an operation and an expression.
Yeah, and that will fail. But it will parse this if this is an expression, this is an operator, and this is an expression. And this will successfully be an expression under this definition of an expression. It's a parentheses followed by a plus b followed by a paren if a plus b is an expression. And a plus b is an expression if A is an expression, and this is an operator, which is plus, and this is an expression. And an expression can be just a variable, which if we follow down what a variable is, that will be an A. So yes, A is an expression, B is an expression, plus is an operator, so this whole thing is an expression. And so parentheses, expression, parentheses, this is an expression. And same thing, C plus D will be an expression, so parentheses, C plus D, parentheses, this whole thing is an expression. And so our original string is an expression, an operator, and an expression, which means that it's an expression. I'm tired of saying expression. But if we write code to do this, if we use these recursive functions, write a function called x, write a function called op, that basically looks for these things, what we can do is as we're going through, we can save what we're parsing, and when we come out of these functions, we'll actually know what the value of this expression was, right? When we get down here where we have this operated with this, take the value of this and this, apply the operation, and we've got the value of this expression. And the parentheses force us to evaluate this, in this case, before we go ahead and do the operation. And it becomes kind of automagical. And I can show you some code next week to do this. But there's all sorts of tools in Linux for doing this. So there's something called Lex. That's a lexical analyzer. And there's something called Yak. Yak stands for Yet Another Compiler. So it's a tool for compiling compilers. Right, so you make a definition of what you want your compiler to do in terms of something like this, and you run it through Yak, and it produces C code that basically parses and compiles according to your language definition. And there's a ton of these, enough that this one was called Yet Another Compiler. And you can buy whole books on just Lex and Yak, and you can lose yourself for a few years in there. I have not gone down that rabbit hole personally. But it's very automatable, and so there's tons of standard tools for doing this. All right, so I'll show you some code on Monday that uses something like a BNF to do arithmetic expression parsing. I wrote my own version of a package for this years ago, and it runs in C, and it just kind of lets you do this stuff. So BNF is another option, and let me see if I can get a network connection really quickly. I just booted, and the first time I boot, Chrome takes forever to load. After that, it just sits in the background and sucks up all my memory, but it loads quickly. Oh, good, we got it. Okay. So here's the BNF for C, programming language. And it's not that long. Well, I mean, a lot of it's like, assignment operators could be any of these things and so on. But this is like the entire C language, right? So a function definition is a declaration specifier, a declarator, declaration, and a compound statement. And what is a compound statement? Well, you can find a entry for that and apply that. There's a compound statement. It's a declaration followed by a statement. What's a statement? It's a labeled statement or an expression or a compound or a selection or an iteration or a jump. It's a lot of different possibilities, and we wouldn't want to use this ourselves, but we could write a program that would be, roughly this long. and we could feed it a big long string, which is a C program source code, and it could tell us if there's any syntax errors in it. Right, and all the information you need to be able to do that is basically described in this BNF. And so most languages you can find a BNF for. So a really, I think, fun kind of exercise to try is to write a compiler. Make up a language and write a compiler for it. It could be a simpler language than C. Right? It might just do a few things. But the process of thinking about how you would do that, how you would break it down and what the different steps would be, right? Even if you don't actually go through those steps, can be sort of useful in terms of thinking about language definition and how you analyze something and see if it follows particular syntax. So that's not a bad activity when you got spare time, you know, which is always hard. All right, so next week I want to talk about state machines. Okay, and we do state machines in 250. I want to visit them from a different perspective. I want to look at them in terms of how they relate to languages. And one thing we'll do with state machines is we'll try to make language recognizers. So you take a string and you want to know, does it follow a certain pattern? Is it an even number of zeros followed by an odd number of ones, for example? And we can design a state machine that will tell us that. Okay, we're not going to design with electronic components, we're just going to do state diagrams. So we'll stay at that higher level. But we'll look at different things we can do with these state machines to either analyze strings, see if they belong to part of a language, or to make changes to them. Toggle every other bit between a 0 and a 1, and so on and so forth. And then I want to talk about Turing machines. So that'll probably be later on Monday or Wednesday. And that's probably our last topic for the course. So Turing machines were developed in the 20s or 30s by Alan Turing and others. And they're basically a model of computation, but every computer that we have in the form of a laptop or a smartphone or an Arduino or a Raspberry Pi is basically a glorified Turing machine. Okay, the architecture of most of today's computers derives directly from these fundamental ideas, and a Turing machine is just a very specific type of state machine. And anything you can do on an Intel processor, you can do on a Turing machine. And the term is Turing complete. When somebody has a model of computation and people want to know what is it good for, the question is generally, is it Turing complete? Can you do anything on here that you can do on a Turing machine? And if you can, then it's considered to be, more interesting because it's generally usable. So that's where we'll probably end up next week. And I'll leave at least Friday for review. But if we finish Turing machines early, we can talk some review on Wednesday. All right, any last questions, concerns on PA2, things like that? Is what? Yeah, I'll post something up. Definitely. All right, cool. Have a good weekend. I will see you next week.